Okay, we are going to go over your position versus time graph notes together. So fill these in as you watch the video. To get started, motion can be shown graphically on a position versus time graph. So position versus time. And bear with me on the handwriting there. You might also see these called distance versus time. They're a little bit different, but very similar in the concept. And then they have a nickname. They're called the X versus Y. Time goes on the X-axis always, and position goes on the Y, or distance. And when describing motion, we sometimes use the word constant. Constant simply means it does not change. So it's the same, doesn't change. And here's an example. If I'm driving at a constant speed of 45 miles per hour, that means my speed stays at exactly 45 miles per hour for the whole time. It does not change. Just really want to emphasize that. Okay, moving on. We're going to look at a distance versus time. Remember that distance is scalar, so it does not tell us direction, it only tells us magnitude. So this slope would tell you speed, technically, because speed is a scalar measurement of how fast something is going. And let's do this example together. We're going to use slope. So remember that slope is the change in rise over run. So y2 minus y1 over x2 minus x1. And it says, what is the speed between 1 and 3 hours? So we look at 1, that's your first point, and 3, that's your second. This is at about 3 kilometers. This is at 1 kilometer. So you would do 3 minus 1. And this is at 3 hours and 1 hour. Over 3 minus 1, which is 2 over 2. Remember to not leave it as a fraction and actually calculate it. So the speed here would be 1 kilometer per hour. And pause the video and see if you can complete the rest of these. And I will go ahead and work those out as well. So between 3 and 5 hours, you don't even really need to do a calculation here because it's staying at the same position for this entire time. It is not moving. So that would be 0 kilometers per hour. And then for this next one, at 5 hours, it is starting at 3 kilometers. At 7 hours, it ends at 7 kilometers. So we do 7 minus 3. So 7 minus 3 over 7 minus 5. You get 4 over 2. Don't forget to calculate it out. And that gives us a speed of 2 kilometers per hour. Okay, moving on in the notes, we have a position versus time graph. So position is a vector. So the slope of this graph tells you the velocity. That is your vector measurement for how fast something is going. This is really important to know that the slope tells you the velocity. And that's because you have position on the y-axis and time on the x. So rise over run for your slope means position over time, or meters over seconds in this case. All right, so what is the velocity between 0 and 5? What's really important to notice here is the negative slope. Negative slope means that it is moving in a negative direction. So it's starting at 7 meters, but it's moving backwards to 2 meters. So that would give us a negative velocity, and that's okay because velocity tells us direction and the negative sign tells us direction. So at 0 seconds, it is at 7 meters. And at 5 seconds, it is at 2 meters. So to calculate that slope, you would do 2 minus 7. And then for the time, 5 minus 0. You get negative 5 over 5, which is equal to negative 1 meters per second. And this makes sense. It tells us that it's moving in a backwards direction at 1 meters per second. So velocity between 5 seconds and 9 seconds, it is not moving. That is important to notice. It's staying in the same position of 2 meters. So it is at 0 meters per second. And now your object has changed direction and it started moving back. I guess you could say in the forward direction towards 7 meters. So you do 7 minus 2, and the time here is 14 minus 9. So you get 5 over 5 and 1 meter per second. The positive there tells us that it is moving in the forward direction at 1 meters per second. And it says during which time intervals is velocity constant, and that is during each interval. So during A, it is constant at negative 1 meters per second. It changes right here to 0, and that's an instantaneous change. And then it changes again right here. So each interval is constant with instantaneous changes in between. Go ahead and do these model problems on your own, and then check the notes key that is provided to you in your notebook.